Hello, I would like to go through Surds. Surds is higher paper only. I'm going to talk about what is actually a surd, and then move on to adding and subtracting, give you some practice on that, and then multiplying and dividing, and then give you some practice on that. And for grade 7 topics will be a rationalized denominator. And then for a bit more difficult is surds and fractions. And in fact, surd is linked to exact value in trigonometry, which is in paper 1. And if you think that this is what you need, this video is for you. What is a surd? We need to use a bit of our Pythagoras theorem knowledge. Look at this length. If I want to find the length of this blue line, I'm going to find the square of this side, which is 3 square, means 9. And then find the square of this one, which is 4 square, 16. By using your Pythagoras knowledge, you know that this part is going to be 16 at 9. It will give you 25 as a total area if that is a square. This length is going to be a square root of 25, means that that length is going to be 5. This is not a surd because that can come to a nice number. But the same knowledge apply, but what makes it a surd is that cannot be square root down to a whole number. Look at this one. That is 1 square is still 1. That part is also 1 square is still 1. If I want to make that a square, that will be 1 add 1, that means 2. The area of this part is going to be 2. Then the length of that diagonal is going to be a root 2. Root 2, I cannot find any whole number time itself to give me a number 2. And that makes it a surd. This is a square and a square number and a square root. But however, on the right hand side, that is a surd. If you put it in a calculator, that surd is going to be a decimal, keep on going. If you understand this, you may be able to understand that because part of this, let me take this off, part of this is a root 2, it's the same length as one diagonal. That is also a root 2. 2 lots of root 2, we can write it as 2 lots of root 2, 2 root 2. This is a root 2. That is also a root 2. 3 lots of root 2, we can write it as 3 root 2. And that is the basic of understanding what is a surd. You know that root 81 is going to be a 9 because that is a square number. And that is a square number and 9 is the square root. And we call that a rational number because we can write it as a ratio, as a fraction. Because that is not ongoing. I can write 9 as a 9 over 1 as a fraction. And then, if we are asking you to square root 80, you know that it will be roughly just below 9 because it's less than 9. It's 8.9442791 ongoing, and that is a surd. So you think about surd as a length, which is an ongoing decimal number, which is very hard for us to tell people the exact value. Therefore, we may want to just keep it like a root 80. And we're going to talk about how to simplify the surd. When it's a surd, we call it irrational number because we cannot write it as a fraction, as a ratio. So let's talk about how to simplify root 80. There are 2 methods. Method 1 is you want to spot how can I break 80 down into at least 1 or more square number. If you cannot spot that now, I can offer you method 2. So let's have a look first. Method 1, can you break down 80 into something is a multiple of any square number, means 4, 9, 16, etc. If you can go straight ahead. But however, sometimes we cannot. Then we can use this ladder method to help you to break it down. Think about the prime number. 2 is the first prime number that can 80 divide into and give you a nice number. And I can do it again for 40. I do it again. And 5 is a prime number and I cannot break it down again. So you can see that is 4, 4 and 5. You can use this 4 times 4 times 5. As you can imagine, we can share the square root symbol for each individual number when it's multiplying. Then the square root of 4 is 2. Square root of 4 is 2 again. We cannot square root the 5, so we leave it as it is. Tidy up, 2 times 2 is 4, root 5. And to simplify it, root 80, that is going to be 4 root 5. Let's do it once more for simplifying 90. If you can break it down into any square number, it will be good. For example, I can see that it's 9 times 10. I put that down into square root of 9 times square root of 10. That will be 3 root 10. For number 10, you can double check. I cannot break it down into any square number because I need 2 of the same number to become a square number. So I am perfectly happy that this is my final answer. However, what if we want to simplify 2 root 90? It's the same. The 2, you write it there first. That means times. And you know that root 90 is 3 root 10. Then the next step is adding and subtracting surds. And now you know why I call this root 2 and why I call this root 5, because the square of that is 1 square. That is 2 square, means 4, and that is 1. If I make that a square, it's going to be 4 add 1 is square root of 5 for this dimension. Because that is equal 5, that 5 is the area, but I just want the dimension of that. Once you understand this, you understand that they are not in the same diagonal, so you cannot extend that correctly. For adding and subtracting surd, if I have 10 root 5, take away 3 root 5. Another way of understanding it is to understand it like in algebra. 10a, take away 3a, you know that is going to be 7a. Same, 10 of the same thing, take away 3 of the same thing, is going to be 7 of the same thing. However, for level 2 is, what if they don't look similar? I cannot just take away 90. I cannot just take away 40 from the 90. I will have to make them a little bit like thinking like like terms. So I have to break them down. Use the same skill as I taught you before to simplify it. Root 90, I can spot that is 9 times 10. That means that root 9 times root 10. That means that is 3 root 10. For the 40, you think about what is a square number. Okay, 4 times 10. Root 4 times root 10. Root 4 is 2 root 10. And then I can actually now take away 3 root 10, take away 2 root 10. It will give you just 1 root 10. And you can just write as root 10. Same, you may have to combine this. So let's have a look. 3 is there first. 25, can I spot a square number? I can find 25. 25 times 2 is going to be 50. So 3 is there. times root 25 is going to be 5. Root 2, it will be still root 2. So tidy up, that's going to be 15 root 2. Then here, 2, 18, I can think of 9 times 2. So 2 still there. Root 9 is become 3. Root 2 is still root 2. Tidy up, 6 root 2. Now you can take it away. 15 root 2, take away 6 root 2 is going to be 9 root 2. So my final answer is going to be 9 root 2. If you want to practice more, here are some questions. Do not use calculator because this is going to be a non-calculator paper. And then pause the video. I'm going to show you the answer in about 5 seconds. Okay, I'm going to let you check the answers. Then the next part is going to be multiplying surds. Multiplying surds, you can combine, because before we break it down, we're actually doing a reverse. Now we don't break it down, we combine them. Then it's basically combine them, and then it's root 10. And I cannot go any further because they cannot cancel each other. They are just how we do the reverse process. Like just now, we can break it down, and this time we are going to combine them. However, you have to look carefully. For example, this one. After I times 5 by 8, I know that it's going to be 40. And I can spot a square number, so 4 times 10. Then you will have to simplify it. Root 4 is 2. Root 10 is still 10. So not always just stop here, because you have to see carefully whether you can break it down into any numbers that consist of any square numbers. Then another level of multiplying surd is with brackets. This is showing you a single bracket first. Single bracket, when you see brackets, is always multiply. 3 times 4, 12. 3 times root 2, 3 lots of root 2 is going to be positive 3 root 2. Think about it, 12 add 3a. So I cannot add anything together because they are now unline terms, a number term, and a terms with the root. So that is my answer. The third level is with 2 brackets. And there are 2 methods. What I'm showing you is the one that using the same skill as we did for single brackets. I found that is the easiest and is the one that you can show neatly and avoid careless mistake. So first of all, your aim, some people will use the grid, and then you will find that that is 4 and then plus root 2, 2 plus root 2, you multiply it. But actually what you are doing is you want the 4 to multiply everything at the back. So that means 4, I got the 4 from here, times everything, because I want to expand the bracket, means that I need to times each other. So that means that I'm going to times it by 2 at root 2. Where do I get the 2 at root 2? I get it from the second bracket. So I use 4 times everything at the back. Then I'm going to bring this down here, that positive root 2. I want the second part to times everything at the back. Where do I get the plus root 2? I get it from the second part of the first bracket. Where do I get the 2 plus root 2 is, again, everything at the back. Then I use the single bracket knowledge. 2 times 4 times 8, 2 is 8. 4 times, that is 4 root 2. Root 2 times 2 is positive 2 root 2. Root 2 times root 2. Now, root 2 times root 2. Think about it. 2 times 2 is 4. Root 4 is 2. Basically, root 2 times root 2, you will have a whole number. So that is something that you should get very familiar with. then it will be a positive 2. Collect like terms. I got the number terms here. That will be 10. Add. I got the terms with the root 2. It will be 6 root 2. And doesn't matter how you write it, you can have it as 6 root 2, add 10. They are perfectly okay as well. Biggest misconception is when it comes to a bracket with the square, some people think that they are going to use the law of indices knowledge. No, you don't use the law of indices knowledge when there is a subtraction or there is an add in between. The safest way to do that is every time you see a square, you write it twice. That means it's 5 take away root 13 times 5 take away root 13. Once you get it twice, and you will know, I want the first part, that 5 times everything at the back. And I want the negative 13, remember that negative there, root 13, times everything at the back. Then again, I'm going to use my single bracket expansions knowledge. 5 times 5 is 25. Take away 5 root 13. Remember the take away there. Take away 5 root 13. Take away and that subtract. Well, negative times a negative is going to be positive. And then root 13 times root 13 is going to be 13. Now that's the most misconception. Again, here they don't cancel down. It's a negative. Take away a negative, it will be more. So 25 add 13 is going to be 38. That will be negative 5 root 13. Take away 5 root 13 is going to be negative 10 root 13. Again, doesn't matter which order you do it. If you do it this way, your answer should look like that. I got more practice on the multiplying surds. I'm going to pause the video in the next 5 seconds. Okay, I'm now going to review the answer. Next part is dividing surds. I don't see a lot of these questions in the past paper. However, it's still a knowledge that you need to know. Multiplying surd, you can multiply the number and then they share the same square root symbol. It's the same. For dividing, you basically can do it by just sharing the same square root symbol, and then you do this one first. The square root is still the same, and then you kind of like do the one in the middle. You can understand it like I got an invisible bracket there, and I will have to do this. 6 go into 72 12 times. And then if they ask you to simplify to your answer, it's going to be 4. It's going to be 4 times 3. That means 2 root 3. Most of the time they will ask you to simplify your answer, but still read the question. For the one with the integer in front, it's the same. And you can make it look like 5 divided by 1 first, and then you can do the root 24 over 3. Imagine that is an invisible bracket there. 5 root 8, and I can see the 8 is going to be 5. 4 times 2, so that means that 5 times 2 times root 2 is going to be 10 root 2. So think about that is an invisible 1 there. Do the number first and then do the surds. Remember there is an invisible bracket, so you can do the bit maths, do the bracket first and then divide and then simplify it further. That will bring me to rationalize the denominator. These 3 look like 3 levels, but it is the same thing, and you will use the skill that we've learned before. Rationalize the denominator means I do not want the denominator to have any square root. To get rid of a square root of 5, I want to square root the 5. That means that root 5 times root 5 will give me an integer of 5. then I have rationalized the denominator. However, I will still need to make sure that the value is the same, so I cannot just change the value. The only way to not change the value is times anything by 1, because any number times by 1 is stay the same. So this part needs to be 1. In order for that part to be 1, my numerator needs to be root 5. Because root 5, the same thing divided by the same thing is 1, then I'm now going to tidy up the numerator. 14 times root 5 will be 14 root 5. That is level 1. That is your final answer. Let's try again. You want to times it by a value of 1, but with the denominator of a root 3, so that is my options. Tidy up. That is going to give me an integer 3. That will give me 9 times root 3 times root 3. That will give me an integer 3. So 9 times 3 divided by 3, that can cancel down, that will be 9. Or if you don't understand this, you can do 27 still divided by 3, it will still give you 9. One more. This time, my denominator is going to be 7. However, you need to remember every time when you have the numerator, it's an invisible bracket there. That means that you are multiplying root 7 with everything inside the bracket. 5 times root 7 is going to be 5 root 7. Take away 2 root 7 times root 7. That will give me an integer 7. So tidy up 7, 5 root 7. Take away 2 times 7 is going to be 14. And that is your answer. And for the final level of rationalize the denominator, you will need to note the knowledge about difference of 2 square. What are difference of 2 square is a square take away b square. It will always expand to be a take away b, a and b. Or you can say that every time you was given a take away b bracket a plus b, you can factorize it to be a square take away b square. The difference means the subtract of 2 square. 1 square is a square, 1 square is b square. Why do I need this knowledge? Is because I want to cancel down my denominator. So basically, it looks like a plus b. Then I will need to match it with a take away b. That means that when I make my choices of that value 1, I need to make sure that that is the same number, but the symbol in between needs to be opposite. That is a plus, I need to put a take away. The numerator is going to be the same. And this is still value of 1, but that will give me the opposite. And let's see what will happen. So basically, if you have these 2 numbers and look at this side, you will have the a take away b, a plus b. So you have difference of 2 square. The first square is going to be 3 square. The second square is going to be root 2 square. Then you can further tidy up. 3 square is 9. Take away root 2 square, cancel each other, basically it's 2. That means your denominator is 7. For your numerator at the top, you got 14 bracket 3 take away root 2. You do the same. 3 times 14, that is going to be 42. Take away 14 root 2. And you can leave it as it is. If the question did not ask for anything specific, that will be your answer. I'll do one more when the sign in between is subtract. Because that is subtract, I need the 2 numbers to be the same. However, I need the opposite sign to the take away, so it's going to be a plus on both. And then think about your difference of 2 square. It will be the square of this and the square of this, and the difference in between. 4 bracket 2 at root 3. 2 square is 4. 3 the root of these squares, cancel it out, take away 3. Basically, it's 1 at the bottom. 4 times 2 is 8. Add 4 times root 3. So the 1 at the denominator is 1. So basically, my answer is going to be this one. Here are some practice on multiplying surds. Basically, is rationalize denominator. 3 levels. One on the left hand side is the simplest one, the middle one, and the one with the difference of 2 squares on the right hand side. And I'm going to show you the answer in 5 seconds. You can pause the video. Okay, this is the answers. Then, the next part is surds and fractions. In order for you to make it easier, you may want to rationalize the denominator first for both, because then it's going to make your life a lot easier. So to rationalize, the one on the left is going to be times it by root 5 times root 5. To rationalize, the one on the right is going to be root 6 over root 6. Let's see what happened on the left hand side. Root 5 times root 5 is going to be 5. 3 root 5. This one 6, then 4 root 6. Then you can see that fractions, I need the fraction denominator to be the same. That will be 30. So in order for me to make the denominator 30, the left hand side I have a times it by 6, the right hand side I have a times it by 5. So tidy that up. That will be 18 root 5. Then this part is going to be 20 root 6. That is 30. I add it up, it's going to be 38. Oh, no, I cannot add it up because they are not like term. I just write it as it is because I cannot make the root 5 is like A. 18A add 20B, so I have to leave it like that, and that is my answer. Here is a practice. They ask you to show that these fractions with the surd can be written in the form of a root b over 6. So you can see that the denominator is going to be 6. What you're going to do is the same. Practice it, and I'm going to show you the answer in 5 seconds. This is the final answer. Then it can be linked to some topics, as I said before, the exact value in trigonometry. This is one of the past paper. Simplify 2 sine 45, take away tan 45 over 4 tan 60. Give your answer in the form of root 8, take away root b over c. And a, b, c are integers. It's a 4-mark questions and there is no calculator involved here. So first of all, you need your knowledge about the exact value. So let's break it down. I want to get my first mark first. If it's overwhelming to you, just break things down. So I'm going to find out my value of sine 45. I'm going to find out my value of tan 45 and also tan 60. Depends on what method you use. The quick method that I use, I will do root over 2, root over root, root and over root. So sine 45, I know that it's going to be root 2 over 2. Tangent 45 is going to be root 2 over root 2 means 1. Tangent 60 is going to be root 3 over 1. That means it's root 3. So I have done 3 things to help me to get at least some of the marks. And I'm going to use this knowledge to replace the value here. So 2 times root over 2, root 2 over 2, that is my 2 sine 45. What I can do is I can make it like 2 over 1. And you may know that the numerator and the denominator can be cancelled out because 2 divided by 2 is 2. That means that if you don't familiar with this, you can rewrite it, and that is going to be 1 cancel out. That means that my answer for the first part is going to be root 2. Tangent 45 is 1 there. Then the 4 tan 60 is still 1. The 4 times root 3, because the root 3 is from here, it's going to be 4 root 3. So you can now finally tidy everything up. The top is going to be root 2, take away 1. Then this part is going to be 4 root 3. Doesn't look like this at the moment, but you can rationalize the denominator. For rationalize denominator, you just need to get rid of this. Then 4 times root 3 times root 3 means 3. 4 times 3 is 12. This part is going to be times everything there. So 3 times root 2, take away 1. Expand it. That is going to be root 6, take away root 3. And that looks like the answer. And that is your answer. Root 6, take away root 3, divided by 12.